What if I told you that the very walls of your house, the sidewalk you walk on, and even the tallest skyscrapers could soon become the world's largest batteries? It sounds like something straight out of a science fiction novel, right? But this isn't fiction. This is the next giant leap in energy technology, and it's happening right now. For decades, we've been obsessed with lithium-ion batteries. They're in our phones, our laptops, our electric cars. But the future of energy isn't inside a tiny cell, it's in the concrete under your feet. Scientists have just made a breakthrough that changes everything we know about power storage, and it could make the traditional power grid obsolete. Today, we're diving deep into the carbon cement supercapacitor. To really get what a game changer this is, we first have to understand the problem with our current energy storage. Standard batteries, like the lithium-ion ones we all know, rely on chemical reactions to start and release energy. Think of it like a tiny, controlled chemical fire. This process is effective, but it has major limitations. They're relatively slow to charge and discharge. They generate heat, which is wasted energy and can be a safety risk. And most importantly, every time you charge and discharge them, the internal chemistry degrades just a little bit. Over time, they lose their ability to hold a charge and eventually, they die. That's why your old phone battery doesn't last a full day anymore. But a supercapacitor, that's a completely different beast. Instead of using chemical reactions, a supercapacitor stores energy in an electric field, kind of like static electricity, but on a massive, controlled scale. This is called electrostatic storage. Because it's a physical process, not a chemical one, it's incredibly fast. Supercapacitors can charge and discharge in seconds, not hours. They can also do this millions of times without any significant degradation. They are far more efficient and have a much longer lifespan than batteries. So, if they're so great, why isn't everything powered by supercapacitors already? The answer is simple: energy density. Or rather, the lack of it. A supercapacitor's ability to store energy is directly related to the surface area of its conductive plates. To store a meaningful amount of power, say, enough to run your home for a day, you would have traditionally needed a device with an impossibly huge surface area, maybe the size of a football field. It just wasn't practical. Until now. Researchers admit, in a flash of genius, looked at this problem and found a solution using two of the most common materials on Earth, cement and carbon. Specifically, a form of carbon called carbon black. This isn't some exotic, newly discovered element. Carbon black is an incredibly fine powder, a byproduct of burning hydrocarbons. It's used in everything from car tires to printer toner. What the MIT team did was mix cement, water, and this ultra-fine carbon black in a very precise way. Here's where the magic happens. When you mix cement and water, they form a dense, strong material. But by adding carbon black, the researchers created something extraordinary. As the cement paste cures and hardens, the water evaporates. This process leaves behind a vast, branching network of tiny, empty channels running all through the concrete like an infinitely complex system of tunnels and pores. Now, because the carbon black particles were mixed in, they coat the inside of this entire network. What you end up with is a fractal-like, electrically conductive web of carbon embedded within the structural cement. The result is a material that is 99% concrete, but has a ridiculously massive internal surface area, perfect for storing an electrical charge. They had created a concrete supercapacitor. Let's put this into perspective. Imagine taking a single block of this special concrete, about 1 cubic meter. The internal conductive surface area created by the carbon network inside that block is enormous. This allows it to store a significant amount of electricity. Now, scale that up. What if the entire foundation of your house was built from this material? We're not talking about a small, separate battery pack. The foundation itself, A structural element that's already there would become the battery. A 45 cubic meter foundation made of this carbon cement could store around 10 kilowatt hours of energy. That's the average daily electricity consumption for a household. This means a house with solar panels on the roof could store all the excess energy it generates during the day directly into its own foundation. When the sun goes down, the house seamlessly switches to drawing power from the concrete it's built on. No more bulky, expensive, and fire-prone lithium-ion battery packs hanging in your garage. No more reliance on the grid to store your excess solar power. Your house literally becomes a self-sufficient energy ecosystem. It produces its own power, stores its own power, and uses its own power. This is distributed energy on a scale we've never seen before. But there's a deeper, even more fascinating layer to this story, which explains why this technology is taking off right now. To perfect these materials, we need to understand exactly how electrons move through them. And that requires looking at the world on the quantum level. Just recently, physicists announced they had performed a perfect version of the famous double-slit experiment. For over a century, this experiment has shown that light and matter, like electrons, can behave as both particles and waves. But we can never observe both properties at the same time. The act of measuring would force it to choose one state. For the first time ever, using incredibly sensitive detectors and clever experimental setups, scientists have managed to watch electrons exist as both waves and particles simultaneously. With atomic-level clarity, we can now see the wave-like nature of an electron spreading out, while also pinpointing its particle-like location. Why does this fundamental physics breakthrough matter for a concrete battery? Because at the nanoscale, the carbon cement mixture isn't just dirt and water. It's a quantum playground. The tiny, branching carbon pathways are the perfect environment for these quantum effects to become significant. By understanding how to control the wave nature of electrons, we can learn how to trap and guide them through these concrete networks with unprecedented efficiency. We are learning how to design materials that move energy faster and store it more densely than ever before, all by mastering the strange rules of the quantum realm. Now, let's think bigger than just houses. This technology is scalable, massively scalable. Imagine an interstate highway built with this carbon cement. The road itself could store enormous amounts of energy, perhaps from solar panels placed alongside it. With wireless charging coils embedded in the pavement, the road could power electric vehicles as they drive. Your EV's range would become practically infinite, as it would be constantly sipping power from the very ground it's traveling on. This would eliminate range anxiety overnight and revolutionize transportation. Picture a bridge with wind turbines attached to its pillars. The bridge itself, made from this supercapacitor concrete, could store the energy generated by the wind, providing a stable power source for nearby communities or for lighting the bridge at night. Or think of skyscrapers in a dense city. Their massive concrete structures could act as giant energy reservoirs, soaking up excess power from the grid during times of low demand and releasing it during peak hours. This would stabilize the entire electrical grid, reducing the need for inefficient peaker power plants that only run a few hours a day. And perhaps the most compelling part of this whole revolution is the cost. Cement is the second most consumed substance on Earth, after water. It's cheap and available everywhere. Carbon black, as we mentioned, is a low-cost industrial byproduct. We aren't talking about digging for rare earth minerals like lithium or cobalt, which are often mined in environmentally sensitive areas and under difficult conditions. We're using the same basic ingredients that the Romans used to build the Pantheon 2,000 years ago, just upgraded with a little bit of 21st century physics magic. The accessibility and low cost of these raw materials mean this technology could be deployed globally, in developed and developing nations alike, without creating new geopolitical dependencies or environmental disasters. We are on the cusp of a paradigm shift. We are moving from a world where energy is a centralized commodity, something we buy from a distant power plant through a web of fragile wires, to a world where our built environment itself becomes our energy source. Energy will be decentralized, resilient, and integrated into the very fabric of our lives. It's not just a new type of battery, it's a new way of thinking about infrastructure, architecture, and our relationship with power itself. So, this brings me to a big question for you. If your home, your road, your entire city could produce and store 100% of its own clean energy, would you ever go back to the old way? What would you do with a world free from power outages and electricity bills? Let me know your thoughts down in the comments. I'd love to hear your ideas. If you love seeing the future before it happens and want to stay ahead of the curve on the biggest breakthroughs in science and technology, make sure you're subscribed and have notifications turned on. We're tracking these developments as they happen, and you won't want to miss what's next. Stay curious, and I'll see you in the next one.